Hello, in this lecture I will introduce measures of location and the most common measures of location that are widely used in statistics and data analysis. By measures of location we refer to a set of numbers which are good representatives of the data, and they are used to summarize the data. What do I mean by good representative? That will come clearer as we discuss the properties of these measures of location. So common measures of location are mean. This is the most widely used and easily understood measure of location. It represents the average value in the sense that it is a number always between the two extremes. So I need not explain this. It is quite obvious that average of a set of number is you add up the numbers and divide by the total number of observation. So I leave it as an exercise to verify that this average will be between the minimum and the maximum of the numbers x1, x2, xn. And also you can see that if I multiply all the numbers x1, x2, xn by a common number a, then the mean of ax1, ax2, axn would be a times the x bar. Median, that is also a very well known measure of location, but this is perhaps a bit more challenging to understand. So median is the middlemost value. What do I mean by that? So we sort the numbers in increasing order. Now x suffix 1 would represents the minimum number and x suffix n would represents the maximum number. Now note that x1, x2, xn need not be equal to this x1, x2 and xn in this order. For example, a set of numbers I can have, let us say 2, -1 and 5. Then x suffix 1 is -1, whereas x1 is 2, and in this way. So I ordered these are called order statistics. Okay. Once you sort the numbers in increasing order, the collection together is called order statistics. And this is a notation that we will be using henceforth, that if I use the third bracket for any real number r, this will represent a natural number such that r is contained between these two natural numbers, and you can always find such a natural number due to a famous property of real numbers called the Archimedean property of real numbers. Okay. What you do is that you sort these numbers in increasing order, and the middlemost value will be this number. So if n is 100, then it will be the 51st observation when sorted in the increasing order. If f is 30, then it will be the 16th number. Similarly, if n is 15, then it will be 15 by 2, that is 7.5. So take the natural number just smaller than 7.5, so 7, and so 7 plus 1, 8. So then the 8th number means when sorted in increasing order, that will be the median. So now it is called the middlemost value. Why? You can see by definition how many numbers are less than the median. So x1, x2 up to xn by 2. So n by 2 observations are less than the median, and similarly n minus n by 2. N minus n by 2 observations are greater than the median. So there are equal number of observations that are above and below the median. So it represents the middlemost value. Mode. The third measure of location is the mode. It is called the most frequent value. Of course, when numbers are all distinct, suppose 1, 2, 3, then what is the mode? It is not clear because each number is occurring once. If you have repetitive numbers, suppose your numbers includes of 0 and 1 occurring again and again, then you can count the number of zeros, number of ones, whichever is more, you call that the mode. When all the numbers are distinct, then it is difficult to define the mode. In that case, of course, we can prepare what we call a frequency table of a given set of numbers, which we learn in the 10th level. That is, you look at the maximum and minimum, that is called the range, divide it into some class intervals, and then find out the frequency of each class interval. By frequency of class intervals, we count the number of observations that are within a class intervals. Then find out the class interval which contains the highest number of observation, or which has the highest frequency. That is called the model class. And then from the model class, we compute the mode by a process of interpolation that I will explain. Then the next is the more general is quantile or percentile. So here from this will be a standard notation henceforth, that is f suffix 1, x suffix 2, x suffix n. This will represent the number in the increasing order. So we call them ordered data or order statistics. So the pth quantile is the n into p plus 1th order statistics, and we are taking the floor of this. That is, if it is a fractional, then we take the natural number just less than this. So how many it represents a value such that only n into p numbers are exceeding this. So if I ask you the 90th percentile, so 90th percentile will represent a number such that only 10% of the numbers are more than this number. This is very widely used these days to report scores. So suppose in his exam you score 90 percentile. Does that mean that you have gotten 90 out of 100? No. So it does not even tell you what your score is. Whatever your score is, it only indicates if you have gotten 90 percentile, it means that whatever you have scored, we don't know that, but only 10% of the students have scored more than you have scored. Now quartiles. Then quartiles are three distinct percentiles. They are 25th to 50th and 75th percentiles, and they divide the data set into 4 parts, because by this concept below 25th percentile there are 25% of the numbers, between 25 and 50th percentile there is again 25%, between 50th and 75th there is 25%, and above 75th as the top 25 percentile. So the numbers that are falling below the 25th percentile are the ones that are the smallest 25%, and those above 75% are the highest 25% numbers. Now finally is a trimmed mean, and so this is an average or a mean, but you don't add all the numbers, you add only those order. If you are calculating 100 into pth percent trimmed mean, then you ignore the n into p percent data from both sides. So below this n order statistic there is n into p observation, so you ignore that, and above this there are n into p observations, and which are the largest n into p observations, so you ignore that. So you let go the smallest n into and the largest n into p observations, and average out the rest. And so if I take 10 percentile, so I would sacrifice 10% data from both ends using the order statistics, and I will be averaging. So how many? And so I am averaging 20% of the data, 80% of the data, remaining 80% of the data that is contained between these two extreme percentiles. Now, what are the advantages and disadvantages, and why each measure of location is of importance, that we will discuss one by one. And so I will start with the mean. I would first let you verify that mean, if you mean is the mean minimizes the square deviations. That is, if I look at insert equation sum I equal to 1 to n xi minus a, yes, whole square. So I have a set of numbers x1, x2, xn. So minimize this function, minimize with respect to a. So you have to x1, x2, xn are fixed set of numbers. A is the variable, so it is a function in A. You have to apply principles of maxima and minima to minimize this function. So take the derivative, equate it to 0, and then solve this equation. Put the value of that A, A, which for which the derivative is 0. So you can easily verify that if I take the derivative with respect to a, this will be minus 2 times summation of xi minus a, equate it to 0, then the solution will be n times a is equal to summation of xi, or a equal to x bar. So a mean is the minimizer of mean square deviations. So we call it square deviations. Why? Because we are taking any number a, take the deviations from xi, and we are squaring and adding them. So mean is that number which minimizes this sum of square deviations. So that is one importance or interpretation of the mean. So next we will show that if I minimize, instead of the sum, if I minimize the absolute deviation, so mode of xi a with respect to a, can you guess what will be this minimizer? So I want you to think over this problem. In this way we will define, we have defined the different measures of location, but we will find out why these measures of locations are interesting or important, and we will investigate their properties. So much for today. Thank you.